Hello everyone, my name is Seven Kai. My matrix number is AE230076. We are from Group 5, Section 3. Today we will present about our project is determining circuit model parameters of three-phase induction motor. In this project, we will doing 4 tasks. The first task is the DC test of three-phase induction motor. The DC test three-phase induction motor is normally used to determine the winding resistance of the stator. This test is important for assessing the condition of the stator windings and for use in further calculation like the copper losses. Now I will show the simulation of this DC test in Simulink. Right, as we can see, the DC test of three-phase induction motor is like this. And when we run the circuit, I will show that the voltage is the VDC is 5 volt and the IDC is 63.86. Okay, now after we doing the simulation, we need to determine the R1. To determine the R1, we need to using the formula, which is R2R1 equals to VDC over IDC. From this, we will get that the R1 is 39.15 milliohm. Okay, now we will discuss about the test 2, which is the block rotor test of three-phase induction motor. For this, the block rotor test, also known as the log rotor test of a three-phase induction motor, usually is to determine the key short circuit parameters of the motor, especially those related to the equivalent circuit and starting performance. Now I will show that the Simulink of this test 2. Okay, as you can see that this one is for the test 2 simulation, and then I will run this. After we run that, we will observe that the V phase is 1 volt and the I phase is 3.379, and the power short circuit is 1.038. And when we need to value the varies is this one. This one we need to change to 2 and then apply and OK. And then we will get the different value from this one. And we will run and we will get that the different value of V phase, I phase, and the power short circuit. And then from this, our group will tabulated this data. Okay, now we will see the tabulated data. And this one is the formula that we will use in this project to determine the ISN, ZLR, and then the RLR, XLR, and the power short circuit. From the power short circuit, we will determine the power factor. And now we will go straight forward to the tabulated data. Okay, in test 2, we will tabulate the data. And this data is determined from the simulation in the Simulink. And the power factor, the average of the power factor is 0.1024, and the RLR is 0.0303, and the XLR is the 0.2943. And from this, we can determine the PCU stator. And we use the I1 square times R1. The I1 is actually the IV. And then the R1 is, we will use the value of test 1, which is the 39.15 milliohm. And then after we sub into this formula, and we will get the values for these 5 different values. And then the PCU rotor is determined by this formula, which is the P short circuit minus PSCU, and we will get the answer like this. And then so for this one is the result from the test 2. That's all from me. Thank you.
Hello everyone, my name is Dong Miao. My metric number is AE230070. And now I'll explain about the test 3, no-load test of three-phase induction motor. The no-load test is to measure the value of the magnetization reactance Xm and the stator copper losses and the rotational losses of the motor. The no-load test is used to obtain the magnetizing branch parameters such as the current and voltage in the induction motor of three-phase. So this is the simulation model of three-phase induction motor using the Simulink in MATLAB software. After we complete build up all the structure, then we go to a synchronous machine and reset the rotor type to squirrel cage. And since we are from group 5, and reset the preset model to number 5, which is 100 horsepower. And the mechanical input is torque, and the frame is rotor. After that, we go to the parameter block and reset the constant value to 220 and multiply it with circ2 in order to get the V phase, I phase, and power short circuit. Next, for the three-phase measurement, we set the voltage measurement to phase to ground in order to get the V phase. Finally, we click the run the simulator, and we will get the value for the V phase, I phase, and power of short circuit. After we run successfully the motor, and we will get this value for V phase, I phase, and power short circuit. All of these values will be recorded in a table to use for calculation. So this is the result of the simulation, and we record it in the table too. After that, we calculate the average of three-phase voltage and the three-phase current in order to get the total resistance. After we get the total resistance, Z equivalence, and we can get the value of Xn using the equation of X1 plus Xn equals to Z equivalence. And we will get the Xn value is equal to 6.25 ohm. To calculate the power of stator copper losses, we use equation of 3I1 squared R1, and we will get the result is 138.8806 watts. To calculate the power of rotational losses of the motor, we use the power of short circuit minus the power of stator copper losses, and we will get the power is equal to 916.1194 watts. That's all for me. I will pass the present to next presenter. Thank you.
A very good day to everyone. My name is Linda. My number matrix is AE230060. Today I will going to present about our actual machine assignment for test 4. It's about study top speed characteristic three-phase induction motor. This is our model that we use the MATLAB Simulink to build up to study the top speed characteristic three-phase induction motor. In this Simulink, we have three-phase voltage to power the motor, and then the display box to display the torque and the rotor speed. The rotor speed, we use the game box to convert from the radian to RPMs. After that, the output we can see from the XY graph here. The RMM box we use for measure the V line and I phase and P power short circuit, or we can say P ins. And this power measurements is used for calculate the for the F for calculate the P ins. These RPMs and this it helps us to identify the ports in the breakdown point as the motor accelerate. So we double click, we set from 10, it give us the good response for when running the models, so that we can see the result from the graph. While the step block we apply it, the look at the fatigue time, and a connection sample and hold back capture the top value at the moment, so showing the motor dynamic response. This is our used to measure how the motor handle the suddenly loads with these two blocks. Now I will start to run out results. First, I will set out all the value that we need to investigate. So the synchronous machine SI unit, the rotor type is select is squirrel cage, and the squirrel cage preset model is depend on our group from. Since our group is from group 5, so the type is choose 5, and the machine input we select speed. So we have to hash applies. This we repeat after this we will use afterwards, and then based on the type we use, the voltage we have to key is 460. Since our voltage we use type 5, it gives us our nominal voltage values, and we have to find the V line, so we have to times square circ2 over circ3 to find the V line. Since our VI measurements we select face to face, if we want to find V phase, we have to select face to ground, so that we can find face V phase, but the V source there we have to only need to times 2 only, so that we can find the V phase and I phase. And then the frequency is all the value we need to study, so we can run it. We get is 404.2 watts, and we can see the graph by double click the XY graph. It will appear graph like this, and we have to find the maximum top Tmax and the end sleep. So we have to use the add-on data caches and then move it into the maximum top of the graph. If our graph is not fit enough, we can practice. It will make sure our graph fit to us to see the measurement to the data caches. So we have to move at the maximum. The maximum is for the top maximum. This is end speed. After getting the top maximum, we can write down here. Top maximum we get from the graph is 1605.2 Newton per meter, and the speed of at the pull out torque is S max equals to S peak over N sink. Before we find S speed max, we have to find the N sink first. N sink is equal to 120 farad over pole. The pole we can find it at this synchronous machine SI unit by clicking it and select parameters, and you see the pole pair. The poles pair, if given pair is mean 2, so two poles pair means 4. So our pole is for our test flow is 4. And then we insert all the values. We get 100, 800 RPMs, and then we insert all the value. The end speed we get from the graph is 1663.6 over 1800, and we get the speed at the pull out torque is 0.9242. And after that, we need to find the efficiency of the induction motor. The output, we can use this. We have to convert into watt, so we have to times 746 times 100 HP. It will convert to watts, divide our P in. Our P in is 404 and 18.446%. After that, the assignment needs us to draw a equivalent circuit. This is our equivalent circuit. So around we will get 5.5679 watt, and that's all from me.